We chose to explore the center of gravity of an irregular object for our project. So the center of gravity is essentially a point from which the weight of a body or system may be considered to act. Now, we decided to calculate it using its equation, which is basically where you multiply the mass, the separate masses, by their coordinates, their x and y coordinates, so that you may get the x coordinate and the y coordinate of the center of mass, or gravity, which is right here. We used these three coordinates, and this is what we were able to get. During our experiment, we were able to see that this triangle reached equilibrium because the pivot point and the center of mass were aligned, which created a net torque of 0. This also means that the sum of forces also totaled to 0 as well.
For this experiment, we used a triangle, a straightest triangle, and we hung our triangle to a pin to observe how gravity acted on the object. And from there, we gathered coordinates, which were these three, and the 3 points of our center of masses to determine the center of gravity.
Separated our triangle into 3 pieces, the weights separately. Then took the height of each piece and divided it by 2 in order to find our y coordinates. And then we took the length and divided it by 2 to find the x coordinate. From our center of masses, we determined our center of gravity. By hanging our triangle by our pivot point, which is right here, to see how gravity would affect it, we then had flipped our triangle to create our x and y axes. From this, we were able to calculate our center of gravity, which lies directly below our pivot point. We had flipped our triangle in order to make it easier to understand, easier to view, and it made it easier for us to calculate our center of gravity.